Hello, and welcome to another episode of Mr. Boskin Does Some Math. Today we are doing Illustrative Math, Grade 8, Unit 8, Lesson 5. So, in this lesson, it's called Reasoning About Square Roots. Our warm-up questions here are true or false. Decide if each statement is true or false. The first question is the square root of 5 squared equals 5. Is that true or false? Well, if we take the square root of 5, we are finding out what number multiplied by itself gives us 5. So if we take whatever number multiplied by itself gives us 5, and then square it, we are going to get 5 back. Now we have the square root of 9 squared equals 3. Well, what's the square root of 9? The square root of 9 is 3. 3 squared is 9. Now, our next one says 7 equals the square root of 7 squared. This one is very similar to the first one that we did, except with things reversed on which side of the equal sign they are on. This is going to be true. The next one is the square root of 10 squared equals 100. The square root of 10, whatever number multiplied by itself gives us 10, times itself should give us 10, not 100. 10 squared is 100. The square root of 16 is 4, and 2 squared is also 4. So that one is true. Okay, the next one here, square root values. What two whole numbers does each square root lie between? The square root of 7. Well, the square root of 9 is 3, and the square root of 4 is 2, so the square root of 7 has to be between 2 and 3. The square root of 16 is 4. The square root of 25 is 5. So this one has to be between 4 and 5. The square root of 50 has to be between, well, what numbers do we know here? The square root of 49 is 7. The square root of 64 is 8. So this has to be between 7 and 8. Square root of 98. Well, we know that the square root of 81 is 9, and the square root of 100 is 10. So this has to be between 9 and 10. Are you ready for more? Can we do better than between 3 and 4 for the square root of 12? Explain a way to figure out if the value is closer to 3.1 or closer to 3.9. Well, halfway between 3.1 and 3.9 is 3.5, or 3.5. 3.5 squared is 12.25. 25. 12.25. Well, 12 is smaller than 12.25. So the square root of 12 has to be less than 3.5. So we know that it is closer to 3.1. Now, before I move on, I should add some other notation for this. To show these as between, we could also show this as 9 is less than the square root of 98, which is less than 10. So this is inequality notation to show what we had written here. So the square root of 98 is between 9 and 10. Okay, our next question. The numbers x, y, and z are positive, and x squared equals 3, y squared equals 16, and z squared equals 30. Plot x, y, and z on the number line. I'm going to quickly write down those numbers over here so we can see them. Okay, we want to plot x, y, and z on our number line. X squared is the square root of 3. So does that mean x goes here? No, we want what value do we multiply by itself to get 3? Well, 1 squared is 1, because 1 times 1 is 1. 2 squared is 4, so the square root of 3 has to be between 1 and 2. Well, is it going to be closer to 1 or closer to 2? Well, let's think. 1.5 squared is 1.5 is 3 over 2. 3 over 2 squared would be 3 over 2 times 3 over 2, which would be 9 over 4. 9/4 would be 2.25. 3 is greater than 2.25, so it would have to be between 1.5 and 2. So I'm going to say x is approximately there. Okay, our next one, y squared equals 16, is a little easier. What number do we square and get 16? Well, that is 4. 4 times 4, 4 squared is 16. So there is our y value. Now z squared is 30. Where's that going to fall? Well, 5 squared is 25. 6 squared is 36, so it has to be between 5 and 6. Which one will it be closer to? 5.5 squared, 5.5 squared would be that's 30.25. So this needs to be just under 5.5. So z is just under 5.5. Okay, our next one says plot negative the square root of 2 on a number line. So the square root of 2, what's the square root of 2? Well, that's approximately 1.4. Because 1.5 times 1.5 is 2.25, which we already talked about when we were doing this one. So it's approximately 1.4, and that's got a negative sign, so we want approximately negative 1.4. And negative 1.4 would be about there. Okay, so we have plotted all of our values on the number line. Our quick summary: in general, we can approximate the values of square roots by observing the whole numbers around it and remembering the relationship between square roots and squares. Here are some examples. The square root of 65 is a little more than 8 because the square root of 65 is a little more than the square root of 64, and the square root of 64 is 8. The square root of 80 is a little less than 9 because the square root of 80 is a little less than the square root of 81, and the square root of 81 is equal to 9. The square root of 75 is between 8 and 9. It's 8 point something because 75 is between 64 and 81. The square root of 75 is approximately 8.67 because 8.67 squared is equal to 75.1689. So this is an approximation because the actual square root of 75 is an irrational number. It would have decimal points that go on forever and never stop or repeat. So here's a number line. Those numbers are approximated on our number line. If we want to find a square root between two whole numbers, we can work in the other direction. For example, since 22 squared is equal to 484 and 23 squared is equal to 529, then we know that the square root of 500, to pick one possibility, is between 22 and 23. So because this is between this number and this number, the square root of it has to be between those values. Many calculators have a square root command which makes it simple to find an approximate value. Your calculator will not give you an exact value, but an approximation, because the actual value of a square root will be an irrational number, which means it will go on forever, it will never stop. The calculator doesn't have enough space to show an infinite number of digits, so what it's giving you will always be an approximation. This has been another episode of Mr. Boskin Does Some Math. Thank you for tuning in. See you next time.